Okay. Take a look at all the answers that I have. Tell me if I'm right or wrong.
That's scary.
Oh, I mean, you can scroll back up. You have the same answers, but that doesn't mean nothing.
Say it again.
Why do you have a leech on there?
One each.
Oh! That's not how you spell leech either.
Leech is too easy.
Leech is
Did
too
you get it? Why people leech on there?
Why isn't there a space between the one and the each?
It's just for me. I was the only person who was supposed to see this.
Well, why'd you show it to us?
Because
Just because you
at one point this was a test for this class.
Thank goodness.
Wait, I want this test. It was fantastic. I want this.
Okay, any questions?
Can you scroll
Get
back
all those right?
Yeah.
Okay. This one you had to say something along the line of this, except it's g of x, not f of x.
So you got it wrong.
Yeah, I got it wrong.
Is that one also a leech?
I did that too.
Two leech, oh, okay.
Okay, moving
I
on.
really like a leech.
Now I couldn't remember because I modified this question further. Did you guys have a plus or a minus?
You were evil and
They're
zero.
minus, yeah.
You had minus?
Yeah.
Okay, so your answer would be 0.
Yes. Correct.
Then I modified it, changed it to be different stuff.
So they would have canceled.
If you change it to a plus, then it cancels and then you get 7. Okay, then 1/2. Okay. You're looking at answers. There's 5 and 6. Good. There's the work for 7 in case you want to do that.
You said we didn't have. You told us to cross.
Okay. You should be getting really good at doing limits as x approaches infinity or negative infinity. Those are like really easy problems. Okay. All right, moving on. Here's 9, 10, and 11.
Are you going over problems right now?
I'll take questions too.
9 in general? How would you?
9 in general. This is the limit as x approaches negative infinity. So you have to think really large negative numbers, like negative 1,000,000. Okay. This is a function where it's 5 plus 3 divided by negative 1,000,000 squared. Well, this part's going to get really close to 0. So it's just 5 plus 0, which is 5. Another way to look at it is the limit of a sum equals the sum of the limits. So that's how why you can do those separately. Any second question?
Oh,
Okay. Alrighty. Okay, next one, 12, 13, and 14. Yep. For 14? What about it? Oh. 14 is one of those that you plug in numerically. All of the other techniques don't work. So you have to just plug in numbers. When all else fails, plug in numbers.
Why is it? Because there's no asymptote? Is that why you know that?
Right.
Okay.
There's no asymptote there because x minus 5 and x minus 5 would technically cancel.
Okay.
And so there's actually a hole in that graph at x equals 5. Okay. Do you understand why number 13 does not exist?
No, not really.
Can I explain that it keeps
Look at the graph on the backboard. This was an answer to this. Do you see how the cosine of 2x, as you approach negative infinity, just oscillates between negative 1 and positive 1? It's because of that. It doesn't matter how far you go down the negative road, you're still going to end up with a number. It's going to oscillate between negative 1 and positive 1. So there is no limit. Because the limit has to be a specific thing, specific number, or it's okay to have infinity or negative infinity, which is not a number. Okay, moving on. 15, 16, and 17.
Is this similar to what our test is gonna be?
Well, just think about it. There's only so many different ways I can ask the questions. So as long as you do enough problems to understand lots of different ones, then you can think your way through any of them. Okay. Everybody understand why this one is 0? Okay. X is approaching infinity, so that means that we're going to plug in really big numbers. So, like 1,000,000. What's 1 divided by 1,000,000? Basically 0. So what's the sign of 0? 0. That's why it's 0.
Yeah, it's the same.
Okay, 18, 19, and 20. Yes? 18. Which? What? Theorem
Yes.
is this? The intermediate value theorem. I just use different letters.
If you write like the grade, if f of k is less than or equal to at c, and then f is like, do you know what I'm trying to say?
Kind of. I think you would have to say that C is any number, well, C is any number between, if you would have said f of k is less than or equal to C, which is less than or equal to f of m,
Yeah.
you're like really super close, it just the language doesn't work out.
Okay.
You know what I mean? Here, we're saying that C is a number that exists between those two functional values.
Would we get it wrong if we worded it like that?
That'd probably be a very minor thing if I did,
Okay.
like a half off or something. Okay, everybody good with those?
Could you go back up to 17?
17, this is just a numerical table where as you come in from the left and the right, you see that the only possible thing is that this thing is getting closer and closer to 2.5. Okay, and that was that. Piece of cake, right? I sent you the answers just in case you get everything there. All right, set that aside. I want to go over a couple of questions from page 205. 205. Dixie, can you just try that first? Just try the first one. I think that might be okay. Joan, does that look all right? Okay. All right. These are the problems that are on the that you had suggested. So let's take a look at them. Number 24, the limit as x approaches infinity of 4 plus 3x. Now look at it. Since x is approaching infinity, we plug in the really big number, like 1,000,000. So this is 4 plus 3 divided by 1,000,000. Okay, that answer is going to be 4. Look at the graph. The end behavior shows you that as x is getting really big, the functional value is getting closer and closer to 4. Okay, this is the visual of that function. So you can see that the answer to this has to be 4. Okay, next one. This is number 25. This is the limit as x is approaching infinity. Now, first of all, you'd look at this and you'd say, okay, who's growing faster, the numerator or the denominator? Numerator is. It's got x squared versus an x. Therefore, this is going to be a slant asymptote, which means the answer is going to be either positive infinity or negative infinity. So then you just plug in numbers. We're approaching infinity, so if you plug in a positive 1 million into here, we're going to think 5 times a million squared divided by a million plus 3, that's a positive number. So the answer has to be positive infinity. If you look at the graph, you'll see that as I approach infinity this way, this thing is going up and up and up and up. It's never coming down. It's approaching infinity. So you get the visual along with the talking through. For a lot of these problems, there's not a lot of work. It's kind of you just thinking through it, you put your answer. Very few ones do you have a lot of work. Okay, here we go. This says the limit as x is approaching negative infinity, so that's a key difference here. X is approaching negative infinity. So, does everybody spot that when you see this, that's 0? Here's 4 divided by x squared. That is going to become 0. So the only thing we have to focus on is the rest of it, 1/2 x. Well, I'm plugging in negative numbers. So this is going to be, if I plug in a negative million, this is going to be negative 1/2 million. Which means that, see the slant asymptote? If further I zoom out here, as x is approaching negative infinity, the y value is approaching negative infinity. These kind of problems, it's all about knowing what you're supposed to look at. Okay, so that's the deal there. That's 205. Here's or 26. Here's number 27. This is one similar to what Gunnar had brought up, which was really good to bring up. This is a weird looking graph. Okay, just take a close look at this. It goes up to here, then it stops, and then there's an asymptote here. Okay, now which is growing faster, the numerator or the denominator? They're growing at the same rate. Because this is x squared, and we're taking the square root of it, so this is really growing at a rate of x to the first. So therefore, this is one of those where the numerator and denominator are growing at the same rate. That means as x is approaching negative infinity, the result is whatever x divided by x squared and then the square root of it is. Now we're going to plug in negative numbers. So this number is negative. It's like a negative million divided by the square root of negative a million squared. So the answer is -1, because the top and the bottom cancel each other out, but the result is negative. It's the same value on the top and the bottom. Now, if we change this so that x was approaching positive infinity, then I'd have a positive on the top, and I would then still have a positive on the bottom. That's why the answer to that one would be x equals 1, or y equals 1. That's the limit is 1. So it matters which direction that you're going, because it matters what the sign of the number is that we're plugging in. Just know this: anytime you're squaring a number, you're turning that result into a positive. And then taking the square root of it, we always take the principal square root, which is always a positive number. This doesn't have two answers here. I know that's kind of a confusing thing at times. There's only one answer when you take the square root, unless you're solving an equation. Yeah.
So, wouldn't it be the same number, like, over each other, so wouldn't that then be positive?
You're exactly right, except you're plugging in a negative number. So the numerator is negative, the bottom is positive, because we're squaring it and then taking the square root. That's the point right there. Okay? And notice this has no impact. The minus x When the numbers are small, like you start plugging in like 1, 2, 3, yeah, that makes a difference. But you can see as you zoom out here, it makes no impact whatsoever. And this whole section was on end behavior, not what happens in the middle. Okay, then 31. Here we're approaching positive infinity. Well, this is kind of a fun graph. Okay, look at this graph. Why does it look like this? Why does it look, if I'm just going to go to the right here so you can see this a little bit better. How come it like shrinks down as it goes to the right? Here, and then as I'm getting here, it's like wiggling closer and closer, and the further I go down here, you see what's happening. Okay? It's still alternating between a positive number and a negative number, but it's getting closer and closer to 0. How come this graph does this? Explanation. Yeah, Kendra?
The top's oscillating and the bottom's getting bigger.
Couldn't have said it better myself. Excellent. The sign of 2x, that's oscillating between positive and negative. And we're taking this answer, which, by the way, this answer right here on the top is always between positive 1 and negative 1. Never gets bigger or smaller than that. But then we're dividing it by x. So as x gets larger and larger and larger, think of plugging a million in. The top number is going to be some number between negative 1 and positive 1. The bottom one is a million, which is why this is approaching 0. This is a fascinating problem because the limit is 0, even though it oscillates between positive and negative numbers. Okay? But each time you move to the right, every step you move to the right, that answer is getting closer and closer to 0. Okay? I should say for every period that you go past, it's getting closer and closer to 0. Does that make sense? This is called a dampening curve, by the way. Dampening curves dampen. That's what dampening looks like. Okay? It's oscillating and dampening all at the same time. Okay, and finally, number 32. We have another dampening curve. It's not oscillating between positive and negative, but it is going up and down, so it is periodic. But as you go, let's see, I'm approaching positive infinity. But as you get larger and larger, values of x, this thing is getting closer and closer to 1 because why? How can we justify that here? It's the limit as x is approaching infinity of x minus the cosine of x divided by x. Why is the answer to this 1 algebraically? Some of the limits, except we have, it's a quotient.
Do x over x minus cosine of x over.
She's got it right on the head here. Limit as x approaches infinity. We're going to divide and conquer this one. X minus cosine of x divided by x is the same as x divided by x minus cosine of x divided by x.
There was a bug over here and we had to kill it, sorry.
He reached his limit.
Yeah, that was the limit.
So, this, of course, is 1. And what is the limit as x approaches infinity of the cosine of x over x? That's going to be 0. Because again, the denominator is growing much faster than the numerator. And so that's why algebraically we can prove it. Of course, visually we can prove it just by looking at it. Make sense? Okay. Now, I want to just show you something else. Okay. Little commentary on forgetting. Okay. When you learn something, it only takes about 3 days for you to completely forget what you learned. Okay? And so, if you think of it, if I teach you something here, okay, the normal thing is, all right, this is how much you remember. Okay, this is how much you remember of what you've learned. 3 days later, we're here. Okay? That's a problem because it was in your short-term memory, but it's not in your long-term memory. Okay? So watch this. If you come back to something again the next day and you take another look at it, what happens is your memory now then goes back up to here, okay? And the graph then, this doesn't exist anymore. Now it's an open circle, and we come up here. It's like a piecewise function. So as the days go on, you forget, and then you're like, oh, there it is. And then what happens is, because you came back to it a second time, it actually sticks a little bit more. And so if you come back to it again the next day, you jump again to here. And the curve starts to not decrease as fast. And so if you were to do an action every day, okay, over and over and over again, that's what allows it to stick in your long-term memory. Okay? And so right here, this is the goal, so that it stays with you for a really long time. I think that probably the simplest example of this is lyrics to a song. You hear a song for the first time, you can't quite sing along with the song. Okay? But if you listen to a song for 100 times, which nobody here has done that, right? Then you can just remember it. I know this for a fact because there was not too long ago, a song came on the radio, and I was in the car, and the song came on, and I hadn't heard it in like 30 years, and bam, I was singing every word. Now I don't even remember what the song was. It was such an obscure song that came on. So I was like, that's really weird, because this had gone on every day, and then I hadn't heard it for so long, and then bam, I remembered it like it was nothing. Okay?
Music's like songs are weird, like the fact that you can like memorize like a whole like.
Yeah.
I don't know, I just think it's weird to me.
Isn't that
And
amazing?
like think of all the songs that you could just flat out straight sing the whole thing.
Yeah.
Right, there's a lot of
Part of it is the repetition. Part of it is another sense. There's another sense to it. Maybe there's a feeling that's associated with it, or a memory that's associated with it, you know, good memory that allows you to do that. Okay? Okay, I promised I wasn't going to talk about homework anymore, but this is one more reason why to do your homework. Okay? It's also a good reason why it's important to spiral what you learn. And the day-to-day thing of just skipping from one thing to the next thing to the next thing without ever coming back to it is bad. So that's why you should be looking at your notes, okay, for the work, because, hey, it's the stuff that you know about. Go review it. Too many people just take notes or whatever, and then they never look at it again. I mean, what is the point of that? Okay? If you want to remember something, just keep doing it, keep looking at it. Which is exactly why I'm giving you another practice exam.
Yay!
Come and get it. Yeah, this is due Monday. No.
I'm enjoying this a little more. Yeah, and you know, we're going to.
I guess so. We have to make a banner.
Yeah, well, I know.
I'm just tired.
But I guess so.
Alright, so this is due Monday. You can jump right in on it right now. We still have some time. Believe it or not, I want everybody to get an A on the test. Okay?
Is this like the format of the test?
It'll be like that. It may not be exactly the same, but you'll see that there's a wide variety of the questions from all the things that we've done. So I'm on your side. I want you to get an A. So